Hello, everyone. My name is Rob Chambers, and I'm an architect in the Cognitive Services group here at Microsoft. In this session, Oliver Schultz is going to talk about unlocking speech recognition in under 10 minutes. Over to you, Oliver.
Thank you, Rob. My name is Oliver Schultz. I'm the program manager for Azure Speech. We'll have something for everybody today in this talk, whether you're completely new to Azure Speech or you've used the service for a long time. Let me start by saying we hope you and your communities are safe. If you're anything like me, you've had interactions in the real world in the last couple of months where you wished you could have used speech technologies. I felt uneasy touching buttons in elevators or touchscreens at the supermarket. Speech technologies make interactions more convenient all the time and safer some of the time too. I want you to take away from this talk today that the Azure Speech Service is a state-of-the-art AI service that is easy to work with. It is packed with rich no-code tools that make it easy for you to adapt the service to your particular scenarios or solutions. And the team behind the service is just as easy to work with. We are super active on GitHub, Stack Overflow, and User Voice for feedback. We love helping you make the most out of our service. We see growing demand for speech services across a variety of industries, and two use cases really stand out. One is deriving data and insights from existing speech interactions. Turning speech into text transcripts is key to unlocking spoken interactions, for example, in call centers or meeting scenarios. Companies want to learn from the customer interactions that are happening in their call centers already. Performing analytics on the text transcripts then reveals insights on what their customers are talking about and how they feel about those topics. And to take it a step further, you can help your customer service agents deliver better customer experiences through real-time AI-assisted insights. Or you can handle calls with bots altogether, like the 170,000 calls per day that the Italian Postal Service Poste Italiane is handling in Italy, where people cannot currently go to their post offices. The other theme that we see is digital assistants. These customer-facing experiences happen on set-top boxes, in hotel rooms, in cars, and other places where companies empower their customers to interact with their products in the most human way, by voice. And in all of those scenarios, just like with a human being, the more context you provide, the more intelligent a conversation you can have. And that is why we believe in customization. We give you access to the tools, training platform, models, and neural net infrastructure that we use to create our high-quality baseline. We built Speech Studio on top of that baseline to make customization easy for anybody. With Speech Studio, you create unique features and models to make the speech service shine for your particular solutions. And once you customize the service and how it works for you, your investment in Azure Speech becomes part of your competitive advantage. Nobody else can use the service in the way you do at that point. Even Microsoft does not see your data. So let me show you a few things in Speech Studio, starting with building a custom speech model. I've prepared a project here already called Biology Lectures. Imagine for a moment I am tasked with taking audio files of biology lectures to transcribe them into text so that we can use it for different purposes. For that, I want to build a model that is really good at transcribing biology speech data. And I've uploaded two different types of data to accomplish this. The first is text training data, and that is data that contains the special terminology that is used in my domain, in this case, biology. And it's really only 116 lines of text. I want you to be aware of that and keep that in mind. And so it doesn't take a lot. And if you're in your particular industry, you probably have a lot of text data that is relevant to your industry terminology. The other piece of data I've uploaded is audio and transcript test data. So those are audio files that represent the types of audio I want to be good at recognizing, and transcripts that are an exact representation of what is being said in that particular piece of audio. So I can use that for testing. Then I've gone and trained a biology model on top of a baseline model that I'm then going to be comparing it to. And that is trained with the text training data. And as you can see here, it's really only 116 lines of text. So let me switch to show you the test I've run now. Now I've compared the accuracy of the baseline model to the accuracy of the biology model. And as you jump in here, you can see at the top, model 1 is my baseline model, and it had a word error rate of 11.62%, or about 12 words that it misrecognized or got incorrectly out of every 100 words. The biology model, though, that I trained on top of that baseline model with 116 lines of text has a word error rate of 3.95%, or 4 words per every 100. And you can see here in the next set of columns the types of errors that we've reduced as well with this new model. Insertion errors, where a word was inserted that wasn't there, got reduced from 14 to 3. Substitution errors, where the wrong word was used, went from 36 down to 13, and deletion from 3 to 2. And at the bottom here, you can see individual pieces of audio that I've chunked into small chunks to make it easier to see the performance changes here. In the first example, the baseline model had a 50% word error rate, or half the words wrong. The newly trained model, 0% word error rate, or perfect recognition. And as you go down here, you see other examples. Let's go to the fourth example. There you see both models had the same word error rate. So this might be an instance where I might go in and take a little bit of this very specialized terminology and update that in the model and train the model one more time. If I've done that a few times, or even just twice, I can then go and deploy the model and add it to my Azure resource that I've already created. From that point forward, any recognition that I send to that particular resource will be recognized using that model. And only I have access to that model. It's now part of my competitive set of assets. So with that, let's switch from the custom speech model to a special custom text-to-speech feature where you can tweak how audio that comes out of text-to-speech sounds. So what I've done here is I've created a couple of examples. Imagine for a moment I'm in a bank and I'm in charge of updating our phone system, our phone banking system, with a couple of new prompts. One of the prompts is to ask customers to enter their account number by speech or by touchpad. And let me see what this sounds like by default if it's just given to the voice.
Please enter your account number by voice or using your keypad.
So the ARIA neural voice sounds really natural and good here, but the tone of the audio isn't quite right. I want it to sound a little softer and just a little bit more friendly. So I see here I've got different styles. One of the styles is customer service. And since I'm in a customer service field, let's try that.
Please enter your account number by voice or using your keypad.
That already sounds a little bit better, but I'm still not quite satisfied with it. I want it to sound a little bit softer and a little bit more unassuming. So what I'm going to do is I'm going to curve the intonation a little bit to phrase this more like a question, even though it's not a question, but I want it to sound as unassuming as a question sounds. So with that, I've tweaked the beginning to go down a little bit and the top to go up a little bit like questions do, because we follow this pitch curve in questions. So let's see what that sounds like.
Please enter your account number by voice or using your keypad.
That sounds a whole lot friendlier already, and I'm quite happy with that. Now let's switch from that and call that done to a different scenario, more a consumer-facing scenario. I have a book, and I want to turn it into an audiobook using these neural voices because they sound so natural. So I have a character in this book that says this particular phrase. They're really excited at this point because they're receiving a gift, and they're really happy about it. So let's see what that sounds like by default if we've not tweaked it.
Thank you so much for this gift. I really love it.
Sounded kind of matter-of-factly, not really excited, not really happy. I'm going to pick a style here as well. I'm going to pick the cheerful style this time. And I also want the word really to be emphasized here. And I know that when we emphasize words, we slow down the rate of speech a little bit. So I'm going to go to right around 50% here. And then I'm going to listen to this again and see what that sounds like.
Thank you so much for this gift. I really love it.
That actually made me smile. That sounded super, super happy, and I'm quite happy with that. And that gives me confidence that I can do this in an entire audiobook and tweak every part of the book that I might want here. If I want to go deep into the technical details, I can look at the SSML here and see how that was created, and I can even integrate that directly into my program. Another thing I can do from here is I can export this data either to my local disk so that I have the audio files to share with others or incorporate into programs or whatever, or I can put it to my Azure Blob storage where I can programmatically use it. I'm not going to do that here now, though. The next thing I want to show you is what we can do with custom neural voices. So the voice you just heard was our ARIA neural voice. That's great. It sounds wonderful. But you can work with us to create your own custom neural voice through our gated premium service. With a custom neural voice, you then extend your brand to include its own voice. We will work with you to coordinate the entire creation process to ensure that you get exactly the voice that you need. Let's hear what a couple of our custom neural voices sound like. I'm going to play for you first the human audio, the recording, and then the custom neural voice.
The New Yorker has a good record of commissioning articles.
That was human.
Can I have your email?
That was custom neural.
It is so exciting to be a part of the team.
That was human.
It is so exciting to be a part of the team.
That was custom neural. And as you can hear, the custom neural voice captures the character of the original voice and is nearly indistinguishable from it. In some cases, the neural voice might even sound a little better to you. Maybe that's because neural voices don't get nervous when they're being recorded. The BBC, Xiaomi, and Swisscom are among the customers who use custom neural voices today. And you can learn more about creating a custom neural voice with us at the Speech Studio website at speech.microsoft.com. Next, we are proud to introduce SPX, a new command line tool that empowers you to use the Azure Speech Service without writing a single line of code. You can use SPX to test your scenario or automate entire end-to-end scenarios via batch files or scripts. Let me demo a few of its capabilities for you here. I've got a command line window open and I've got a few commands that I want to show you. The first one is a straightforward command where I'm telling SPX to recognize from my microphone. And so I'm going to hit enter on this. Hello, my name is Oliver. I'm demonstrating Windows. I'm demonstrating speech recognition. And as you can see, it recognized everything I said perfectly. It even put punctuation in the right places for you here. So let me now go and demonstrate something slightly more advanced than that. And that is the SPX recognize from file command. So I've got SPX, I'm telling it to recognize files this time from this directory, all of the WAV files, and I'm asking it to write the output to a demo.tsv file that I'll show you in a moment. And I'm asking it to do this on 4 threads. I'm doing 4 threads because I've got 4 files here. Your thread number is really limited only by the power of your machine. So it's recognizing these files now, and it's doing this in 3 seconds. That's actually faster than real time for these files. And here's the file that it created, the output file. As you can see, the file names are in here, the recognizer session ID, if you have the need for debugging. And then here are the recognized results. And even dates and phone numbers and addresses will be properly formatted here. And you see all the punctuation in here as well. So that is this. And now I'm going to switch to text-to-speech again, like I did earlier, and explain a different scenario. So the scenario that we have here is I want to take a game, and props to you if you can guess which game this is, and I want to enable the characters to speak via our neural voices that we have here, via some of our TTS voices. I'm going to create a few of these in different accents so I can hear what that sounds like. I'm going to use an American accent, an Australian accent, and even a foreign accent for these files. I'm going to tell SPX to do this in one go with a single command. So I'm going to tell SPX to synthesize for each line in that text file that I just showed you and do this on 3 threads. And it should do that really quickly. And I've got an error here. Thankfully, I've already done this a couple of times before. And I'm just going to play these files for you that it created earlier on one of my test runs. So here, I'm going to play these files back for you.
Nothing is true. Everything is permitted.
Nothing is true. Everything is permitted.
Nothing is true. Everything is permitted.
And I really like the French accent here because it goes with one of the characters in the game who actually has a French accent. So that's lovely. Now I'm going to take SPX and do yet one more thing that it can do, which is to translate audio files. So I'm going to tell SPX to translate from a file. I'm going to take one of the files that I just created, the Australian English accent. I'm going to tell it the source language and the target language, in this case, German. And as you can see here, nothing is true, everything is permitted, got properly translated into German. That's nice, and I can tell because I am German. So that was the demo of SPX. I just showed you some of the top line commands that you can perform here. If you're in a call center environment, you can point SPX at your cloud storage location as well, where you store all your call recordings and transcribe those with the batch transcription command. That offloads the work from your local machine to the speech service that will pull these files in. SPX also supports more advanced features like creating your own custom models or calculating word error rates between transcripts and recognitions. You'll find these all documented in the tool documentation and in the tool help files as well. You can download the tool today at this website under the tools domain, under the tools tile that we have there. And here's a quick update on a new feature. We now support speaker recognition. This feature answers the questions, who is speaking and is this person who they claim to be? Our customer AWM built an employee access solution by combining speaker recognition with Azure Face Recognition as an alternative to card keys. In telephone banking, you may want to verify your customers by their voice instead of easily compromised data like their mother's maiden name. In digital assistant scenarios, you can use speaker recognition when you may want to take different actions based on what you know about the speaker's preferences. For example, when they say things like play a movie. Speaker recognition will release a new version of its API on June 1st, and that'll be fully integrated into the Azure Speech SDK. And it'll work with your existing speech service subscription key. And it'll support 8 languages. Now let's briefly touch on deployment. The Azure Speech Service is very flexible here. It can be deployed in the cloud or on-prem. Containers bring the speech service APIs to your on-prem environment where your other services are already running. You may want to run a container because of security or privacy regulations in your industry, for example. Containers are currently in public preview with some features like neural TTS in private preview. Our customer KPMG uses containers to help their customers meet changing compliance regulations and reduce operational effort and costs as well. And before we go to Q&A, I want to mention a couple of customer success stories. Capita Consulting in the UK used our customization tools to save time and create a powerful financial services model. You can read the details of their scenario on the screen here. Focus on the bold text. It's really quite impressive. Similarly, our partner Zen3 in India uses the speech service to gain a 360-degree view of their customer experience in call centers. With that, I thank you for giving me an opportunity to tell you about the Azure Speech Service today, and we are super excited to see what you will build on our platform. I'll leave this on the screen while we go to Q&A. Rob?
Thank you very much, Oliver. That's a great presentation. We've got some Q&A. We can open it up. We've got a couple kind of questions there. One of the questions that came up was around customization, and the question was around SRGS support, which is a W3C standard for improving accuracy of speech recognition results. The question was around, is that supported anymore? If not, why? Do you remember using SRGS way back when we were working on Windows speech recognition?
Yes,
long
it's been
ago.
a long time.
That was like almost 20 years ago, right?
Yeah.
So although the speech recognition system in Windows does still support that, it is quite older technology compared with what we have here with Azure Speech. And with Azure Speech, our default base models are very, very good, as Oliver had pointed out. And if you do need to customize, SRGS is one way to do it in an old style, but it's very limited. The kinds of things we can do with the custom speech portal are far more sophisticated than we've ever had in the previous speech systems. So I would encourage you, those of you that want to try to improve that speech recognition accuracy, to check out the custom speech portal. I also know that the team's been working on a lot of other capabilities, and so what are some other things that we're announcing new at this time?
Yeah, we've got a few other updates that we've made to speech to text, for example. On that side, we are making great progress in expanding our language coverage. We've added 5 new locales for over 40 locales total now, with 20 more coming very soon. And we also continue to make great progress on the accuracy front, with an average improvement in word error rate of 30% across 29 locales. We've also added 10 new auto-punctuation locales so that your output for those languages is better formatted with punctuation in the right places. And we have updated transcription models to perform better in telephony scenarios as well. So we've got quite a few changes on the speech-to-text side. On the text-to-speech side, we now support 21 neural voices across 16 languages. 3 of those voices support speaking styles like I showed you earlier, like the customer service, newscast, assistant, and so forth. These voices sound, as you heard, incredibly lifelike. And we've also reduced pronunciation errors here by an average of 50% across 13 locales. 11 of our neural voices can also now be used in a bilingual context, which is really kind of cool, especially for people who are bilingual like me. Then our long-form audio API now supports neural voices as well, so that you can create audiobooks like I showed you. And those are some of the high-level updates that we've got in speech-to-text. 2 more things I'm going to fit in, or 3 more really, that are quite exciting. We now support the Go programming language, and our documentation has been updated to reflect that. And you can see that and dive deep and see what you can do with that. It's really cool. And then we have a new speech services REST API. This is our version 3 out that does a whole bunch of things that the old API didn't do, like a batch transcription, for example. It's a big step forward for us. And then we've got a custom command updates as well. There's a targeted talk that we have for this, an on-demand session for this as well, called Building Voice Assistants with Custom Commands.
Excellent. Thank you for that update.
Yeah.
Another question that came up in the chat is around the demos. And so those demos that you were doing from the command prompt, the question was, is that integrated into, is that the SDK itself, or is that a separate tool or a separate download?
So that is a separate tool that we just put out today. Actually, it's on the web. Actually, yesterday, it's on the website. You can download it now. You go to aka.ms/speech/SDK, and there's a tools section there, and it's a separate downloadable tool that you put on your machine, and then you run it from there. And it uses your subscription ID and your region that you first have to give to it as part of the config step for it, and then everything that you do with it goes against your subscription, and you can use custom models with it that you create, and it's quite the fun tool. I really only scratched the surface here.
Excellent. Thank you very much. Another question we have from the participants is around, if you're in a call center scenario and you had a lot of audio data along with those transcriptions, if you're trying to recognize them, maybe with specs or something else, what could you do could you use those recordings to actually make the recognition process even better?
Yeah, there are a couple of things that you can do to make the recognition process, the accuracy better. So for example, you could create your own custom model. For that, generally speaking, what you would do is one of a couple of approaches. You can do what I just showed you here. You can use custom speech to create a custom speech model for yourself using data that you already have in your organization. Say you're an insurance company and you have lots of brochures about the different types of insurance that you sell, and the terminology is captured in there that is special. Or in your internal documentation, you use that and you build on top of a baseline model and you create a better model. But what you could also do is you could use your existing audio data and have some of it human transcribed and use that as training data for your model as well, using the custom speech interface. Or you could use SPX directly to train your model program, like from there, from the command line.
Excellent. And so there's a related follow-on question to the question around SRGS support. And so one of the, if you remember way back when, SRGS also supports semantic interpretations. And so you can attach different meanings to, like, these 3 words mean, look at the end of the document versus at the beginning of the document for different 3 words, right? And so the question was, how can we, if a user wanted to have some kind of semantic interpretation or language understanding, how would that work with the speech system? Or are there any other integrations or things they could take advantage of?
Yeah, Rob, do you want to touch on this a little bit? I think
I
the Lewis integration, I think, would be one thing, and there are other, yeah.
Yeah, so from there are two sort of answers I guess I'd put here. The first one is, if they are very simple types of semantic interpretations where, like, this exact set of words is this exact command. Like it's a very command and control operated sort of system. You can use an object from our SDK that's called the intent recognizer, and you can add those phrases one by one with, a semantic sort of an action ID or an intent ID. And then once the speech system recognizes the text, not only do you get that text, but we'll also give you what that intent ID is. And that's independent from the cognitive service, the language understanding service. But in addition to that same object, that same intent recognizer object in the SDK, you can also use the facilities of the language understanding or LUIS cognitive service. And you can build a full-blown model that is significantly better and more advanced than anything that SRGS could provide to you. It supports entities, it supports intents, it supports various kinds of patterns with regular expressions and other things. And the integration with speech is done in a way that when we're doing the speech recognition, as we're getting interpretations, we actually communicate back over to the language understanding service in the back end to increase the performance and the speed of the system. And then we'll get that language understanding result back from the cognitive service, and then return that back to you through the result that pops out of the SDK object. And so the nice thing about LUIS is it enables a very large recall system. So with SRGS, it's very fixed, very sort of, if you don't say exactly the thing in SRGS, it's not going to work. Whereas if you use something much more advanced like the language understanding service, it's got much better recall. You can say things that are kind of nearby. It's got a great training user experience where you can look at things that users have spoken that weren't classified well, and you can classify them. Really, really nice system. So I'd encourage you to check out the language understanding portal and also check out the intent recognizer in the SDK. Okay, so there was a question about the other sessions that we have on speech.
Yeah, those are these two on-demand sessions that are actually available now. In channel 9, I believe it is that these can be shown. I think they'll be shown after this talk as well. One is to really dive deep on the customer service scenario, where Panos is going to demonstrate how customers can use our ready-to-go samples to get the most out of their call center audio. And then the other one we have is the voice assistance through custom commands talk that gives you an overview of how you can build your own custom commands to really enable the scenario that you've got on the digital assistant side.
Great, thank you. So we've only got a couple minutes left, and I know one of the things that's nice to understand when I join one of these kinds of presentations is to learn a little bit more about the team itself and the people behind it. And so I know that you've been working on speech for quite a long time as a bunch of people in the speech team. What have you seen over that very long period that's changed a lot since when you first started working on speech that you're impressed by?
I think for me the biggest thing that I love seeing is how much more ready the general population is to interact with technology by voice. That didn't always used to be the case, but now there's been this sort of groundswell of functionality that's been widely accepted and adopted across the population, be that in your digital assistants on smart speakers that you have in your home or on your mobile devices, where people generally prefer entry or text entry or information entry in general via text, be that dictating to your emails or your text messages. I see this particularly in when every time I'm out in the world with a realtor, they do everything by voice, and that a while ago was unthinkable, right? Because also generally speaking, realtors tend to be of a generation that isn't the first to adopt technology, but they're right there with it. And so there's lots of adoption and lots of acceptance of that technology. And that to me is super impressive. And that gives me a lot of hope for really making machines work more like humans rather than the other way around. We're coming out of this long period where we've always forced humans to work like machines. And that's dramatically changing.
That's great. Well, we are out of time. So thank you very much, everyone, for attending. Thanks for all the great questions. Be sure and check out the other two on-demand sessions. Oliver, are there any closing thoughts for you?
No, thank you so much for, other than that, to say thank you. We can't wait to see what you're going to build on this, and we look forward to you interacting with us, be that on GitHub or Stack Overflow, or giving us feedback on user voice. We try to be super responsive in all of those channels, and we love working with you on building stuff.
Great. Thank you.
Thank you.